Thank you all for being here. I am so excited about this question that we're going to actually start this conversation with answering that question and kind of talking about our expertise and how we can kind of help society answer that question. So for Phnam and Aenor and Aparna, let's go in this order. And I'm going to say using your expertise, thinking about that, how would you answer, should humans go into space, live in space?
Hello, everyone. Thank you so much for having me. Thank you, Regina, for being the moderator that we need tonight.
Yeah. Do we need it? I don't know.
Yes. So I am a space architect. So for those who have never heard these two words connected together, a space architect is someone who designs living environments for astronauts to live and thrive in space. Yes, it's a real job. And
real job. Right.
And the other thing that I do is I also turn technology into products that bring positive impact in the world. Everything from medical devices, renewable energy solutions, and things of the sort. And I do that on Earth and in space. And really, the bridge between the two, what we develop in space, because the space environment is so difficult and in every way designed to kill us. And then how do we bring it down to Earth to benefit the people we live with one way or another? And so that's really what's at the core of how I would answer this question of should we live in space? I think there's a beautiful acceleration of innovation that happens in extreme environments, and there's no more extreme environments than space.
Yeah.
Everything is different. Nothing can be taken for granted. The air that you breathe right now, or the water that comes out of the faucet that you're drinking, or the food that you have access to. All of these elements need to be brought in space or come from resources that are not necessarily easy to have access to.
Yeah.
Just to give a context to everyone, we can, as humans, we can live 3 weeks without food. We can live 3 days without water. We can, food, water. We can
sleep.
Yeah, sleep. Not that long, really.
Not that long.
Just a few days.
Yeah.
And we can survive 3 seconds without pressure. So all of these need to be artificially created for these humans to not only survive, but also live comfortably and hopefully in the future thrive in space. And so as someone who works as a space architect, I think about those life support systems that we integrate into these architecture that keep us alive, but also think about what we need beyond that. Do we only eat for sustenance, or do we eat for pleasure? Do we eat for culture? Do we eat for variety, right? There's a physical and a psychological consequence in giving these options to these astronauts. What does agency mean in an environment that is so closed, right? And you're seeing the same people, relying on the same people to survive in this environment. When you go on a mission, what is the priority? Is it keeping people alive? Is it the mission itself? How do you balance between the two? When your schedule is packed from early in the morning until late at night with activities of maintenance, working out, doing all the scientific work that you have to do up there, how do you rest? Do people actually design your mission so you can rest and recover, right? So all of these questions, how we design this environment, how we support our circadian rhythm and all the natural rhythm that make us human, how we support our own identity and how we support our own cultures as we develop ourselves in the solar system as a species, these are questions we don't necessarily have answers to today. And it will be incredibly important and interesting for us to start getting answers. And so,
before we can answer, should.
Yeah. So let's go. Let's go to space.
Yeah. That's good. Aenor, what about you? With your expertise as a medical professional, should humans live in space?
Well, the punchline is we should go to space. And as long as we have humans existing in space for whatever period of time they need to be up there, we should do it in a way that optimizes their safety and their health while they're there, but also minimizes negative consequences when they return. My background is I trained as a physical therapist first, then an exercise physiologist, and then I became an orthopedic surgeon. And now I am very involved in the Skeletal Health program, which I founded at UCSF, and the UC Space Health program. And I'm executive director for innovation and entrepreneurship at UCSF in our Innovation Ventures program. All of that sounds probably like some person who couldn't figure out what they were doing, but it all comes together. It all intersects. And partly, it helps me move closer and closer to my goal of creating distributed healthcare, distributed but not diluted or diluted healthcare. So the best care we can give, but not dependent on very expensive, high resource settings, but trying to give the best care and enable people to care best for themselves remotely. So this is why I'm driven to do some of the work I do in space, because it is the forcing function or the edge case for truly distributed healthcare and moves us from a tethered model, whether you're tethered to a tertiary care center or you're tethered to the ISS telemedicine model, but it moves us as we go to deep space further to an augmented model and eventually to an autonomous model of self-care, self-reliance, et cetera. And we can get more into that in a little bit, but the question is, should we live in space? I think we should definitely go to space. And the reason is that we have already benefited so much from the science that can be conducted there uniquely, that we can create analogs and do all kinds of interesting simulations here. But there are circumstances and conditions up there that we can't fully reproduce here. And we've already demonstrated significant benefits terrestrially, not just in healthcare, but obviously Wi-Fi, imaging, all types of things. And so people ask me, why do I invest my time, my expertise, my passion in space research? And it's rather than focusing on what, there are people driven by different incentives who might be looking at what's called the ROI, or the return on investment. I look at the ROE, which is the return on Earth. And so that's a phrase I've coined that actually makes it a very short answer to that question, which I've had to answer for several years. I love space science. I'm an Air Force brat and a space and flight nerd, but I really care about what I can learn about distributed healthcare models in that type of environment that I can bring back and benefit people on Earth with.
Yeah, thank you. Aparna, as somebody who studies space, right? Who studies the origin of everything, should humans live in space?
Thank you, Regina, and everybody. Thank you for sharing your Thursday evening with us, and huge thanks to Sam and Amanda, and also the tech staff. Thank you.
Yep.
I am a cosmologist by training, so I study the earliest objects in the universe, the most ancient objects. But the last few years have walked the path of dark skies advocacy, because the dark skies we need to do the work we do as astronomers is quickly being lost to increasing ground and space-based light pollution. So I've now begun to think not just about the ancient objects that I study, but our ancient relationship with the night skies, the timeless relationship we've had for millennia with our unaided human eye, with the skies, the planets, the stars, the moon, and so on. I think of us going to space as a return to space because we are all 14 billion years old, plus or minus 20, 30, 50, 70 years. We're all 14 billion years old, and we are off space. That was our first home. So in some ways, I think of this as a return to space, but now as a species capable of great technological brilliance and creativity, but also great destruction. So I think our knowledge systems and our science and our ethics will be put to the test by returning to space. we are a curious species. We like to travel. I think it's one of our greatest qualities. And I am very curious what it will be like to live in space for extended periods of time. I think we'll learn a lot for medicine and education, and of course science. The kind of science experiments planned for the far side of the moon will be especially of interest to my research specialty. So I'm very excited about that. But I also think, and I'll return to this later on this panel, we're doing things in a tremendous rush, and if we could just slow down and do it more intentionally, I think we could develop entire new frameworks of doing science ethically and sustainably. So I think there's a lot to learn from going to space as scientists, as artists, as storytellers, and so much more. I know that I am changed by our views from space. Like when we experience an eclipse on Earth, it is miraculous. But when I see the data from the International Space Station or other satellites showing the eclipse shadow sweeping across Earth, or an eclipse from Mars off the sun by one of its very small lumpy moons, I mean, it changes my sense of who I am. So I do think we're on the cusp of this era where we're poised on the edge of tremendous discovery and understanding of the universe, but also understanding of ourselves, what it means to be human.
That's beautiful. But if you want to see a solar eclipse, it's happening in August 12th in Spain and Iceland. Just heads up. It's going to be really expensive to go. But with that, let's actually talk. Phnam, I'm going to ask you first, but please, Aenor and Aparna, like if you want to jump in and you have thoughts too, please do. It's going to be free form here. We're going to talk about these buildings you're talking about. So let's talk about like these physical environments that, you know, your company and the things you work on, but also like what do humans need to live in space? And then we can kind of also get into that like mental, like the other things we need to build that aren't as physical. But let's start with the physical. So what do we need to build?
All right, so as a space architect, I get involved in designing architecture in free space. So things like orbital structures like the International Space Station, or things on the surface of the moon or on Mars. And so what's different between all of these environments is the gravity. When you are floating on low Earth orbit, which is about 250 miles away from the surface of the Earth, you are essentially constantly falling. That's what makes you float, right? It sounds very nauseating, and it is, but that's what's happening. And we have gathered a lot of data on what happens to the human body, and I'm sure Aenor can develop that a lot more on all the things that happen to our body that are quite negative, right? Like space blindness and kidney disease, you know, being nauseous for the first 3 or 4 days you're there, you know, a lot more blood in the top half of your body, which is not what we used to when you live on planet Earth. Every single one of your system is messed up, basically. You're also orbiting around the Earth, if your body ISS, 16 times a day, which means that you experience 16 sunrises and sunsets a day.
It's fast.
Your biology is not used to that. And also the light that comes from the Earth and the sun are extremely different from what we used to, right? Like here in the morning, we experience the blues and the pinks, and in the evening, we experience a lot of oranges and reds. And that's what we've been used to for millions of years, or 14 billion years plus whatever age you are.
Like 13.8, actually. No,
all right.
No.
And so
Thanks,
as someone who creates artificial environments that supports the health and well-being of humans, we have to get more and more precise about what we're offering, right? The shelter, the protection from radiation and from micrometeorites or from debris, right? That's, yeah.
I didn't even think of the meteorites. I always think about the radiation, but like, yeah, things are just going to shoot through your stuff.
Yeah, it's quite dangerous. and the circadian rhythm, the fact that we are biologically, every single aspect of our body is based on 24-hour cycles. So how do we create the artificial systems, whether it's a light system, a smell system, a food system, a schedule system, that supports all of that? And how do we also create a methodology to support each individual's needs? Because right now, the way we're designing all of this is we have experts, in all of these different disciplines, in food and lighting and in life support system and all that are working their best to create environments that people can survive in. But how do we adapt to each person, if you're in a bad mood one morning, or if you're tired, or if you're sick, you have different needs. And if your system that's designed around you is very limited and it does not support what you need whenever you need it, that is a problem. And it starts accumulating over time, and there's no space to walk out, open the window and get some air. That's not a thing up there. How do you support all of that in missions that are getting longer and longer, right? So aboard the ISS, for example, astronauts stay about 6 months aboard, basically talking
or they get stuck for a year.
They can. When we decide to go to Mars, that's going to be 2.5, 3 years mission back and forth. That's asking a lot. So architecturally, there's a lot to be done. Biologically, there's a lot to be done. And there's a lot of talks that is inspired by science fiction, like biostasis, or the preservation of organs, or cryosleep, or different types of propulsions that can perhaps get us there much faster and back. So the integration of the technological innovation, the hardware systems innovation, the software system innovation, and how the human systems are integrated in all of this, and the feedback loop that feeds evolution over time, so things adapt to you instead of you adapting to it, is going to be at the core of how the future of space architecture as a field is going to evolve.
Yeah. Do either of you have any questions about that, or even thinking about the medical parts of what's the hardest medical challenge that that we're thinking about?
I think the hardest challenge is the factors that we depend on to not just survive, but to thrive are all missing up there.
Yeah.
So whether it's food, water, air, or the right mix of air even. So it's not just providing oxygen, but minimizing the carbon dioxide, the nitrogen, et cetera. So the right balance of air. And then also the support, so the countermeasures against the unintended consequences or the negative effects of microgravity. So muscle loss, bone loss, cephalad fluid shifts, and all the changes that happen physiologically, the countermeasures against those, and finally the protection against extreme temperatures, radiation, and collision.
Yeah.
So those are the things we have to provide, that they are essential for survival, but also if people are going to go for any length of time, they also need to thrive. They need to thrive physically and psychologically. The other thing that I think about is we need a paradigm shift. Our current model, at least for health and medical, and most of our system support is a telemedicine model. We're very earth-tethered in the ISS. We're fortunate. It works phenomenally well. For 25 years, we've had terrific science returned to us from there. But it's basically very Earth-dependent right now. We can resupply, we can deorbit if someone has really reached a level of acuity medically that we need to get them out and get them back to Earth to care for them. We can also very much have synchronous, continuous communications. So we could do an ultrasound up there. Person doesn't even have to know how to interpret it. It gets pushed to mission control, interpreted, action plan gets sent back up. So we're very Earth dependent. We need a huge paradigm shift, even to go cislunar to the moon. So Earth is, LEO, low Earth orbit, is hundreds of miles away.
Yeah.
About 250.
It's actually not that far, weirdly.
It's easier to get people back from the ISS than from the Australian Antarctic base station that we do research in as well. But it's important to know that when we go to the moon, so we're going from hundreds of miles to hundreds of thousands of miles away, and Mars is hundreds of millions of miles away. So keep that scale in mind, and it tells you the requirements, the functional requirements are changing dramatically. So we have to have a paradigm shift in how we do all of our systems. When we get to the moon, resupply is harder but possible. Deorbit, much slower, but also the concept of synchronous communication, which we're very dependent on right now. As you know, you saw the delay. We all watched it with Artemis 2. It can become even more significant than what they demonstrated. That was such a beautifully executed mission all in all. So those are things that we can't have as just our dependencies. We've got to mitigate around those and move to more of an augmented model. But all the time moving towards deep space, it's going to have to be autonomous, which means even our, not just the spacecraft, but our human systems have to become more closed loop processes where we're sensing relevant information from the human in the context of their environment, and we're actioning that information. So we have to have edge analytics and turn that into actionable insights, and then we've got to have the capability to act on those insights.
And by edge analytics, you mean like that, like
on-prem compute.
Okay.
So you've got to be able to collect the data, but you've got to interpret what that data means. You've got to
in
analyze
that moment.
it. And then you have to turn it into something that's actionable. You've got to turn it into information, not just data. And then you've got to have the ability to act on it. And you know, that in the medical world opens up a lot of possible scenarios. So there's also a whole risk prediction modeling that's going on. And NASA's working very much on these Earth-independent operations or Earth-independent medical operations in terms of the environment controls, but also the life support systems. I might have gone on a little too long, but
No,
I get very excited about it.
Aparna, Aparna's over there. Phnam, you seem to want to add to that. Do you have anything to add?
Yeah, just adding on to what Aenor is talking about. There are some things we can do to test what she's talking about without having to go to space. Right? There's such a thing as what's called analog missions. So going to Antarctica, or actually last year I went near the North Pole on a research station called Flashline. Organized by the Mars Society, and basically living in that environment, extremely isolated. We use software to create artificial delay as if we were on the surface of Mars. So it was about like a 40-minute delay going both ways. And understanding what really happens physically and psychologically in terms of risk, medical risk or otherwise, when you are in true isolation, right? So thankfully, in our case, our mission, nothing happened that was dramatic. However, the mission that came immediately afterwards required an evacuation.
Wow.
Yeah, it was a lot.
And yours was like smooth sailing.
Super smooth sailing. I'm going back. I can't wait. It was fantastic. But it does happen. And what was very interesting about the evacuation, it was done with someone, the last person I thought would need an evacuation.
Yeah.
Right. So there's a lot of unknown. There's a lot. You can test. You can ask all the questionnaires you want. You can take all the bloods and stool samples that you want. Nothing is going to tell you what's actually going to happen when it happens.
Yeah, you'd really need these. I was going to say, Aparna, I'm like, what is this paradigm shift that we're talking about? These thoughts,
I just had a question for the two of you. I think there are things we can measure, and then there are things that we cannot. I know it's a topic for college application essays, grit, resilience, but we can't measure that stuff. And this is the thing, right? Somebody may have perfect blood work, but maybe less or more resilient relative to others in these.
Or interpersonal skills.
Right, like we can calculate e-folding timescales of how quickly things devolve to a high school dynamic, like cliques form, and I don't know, so I am curious for the two of you. I know we'll move on to Aenor sharing more about her work, but just how these environments it's my understanding that our immunity dramatically drops in space, and that often viruses get stronger in space. So I just it really does feel like we're venturing into the unknown, not knowing what our immunity will do. I was saying this before we came on here, that I'm curious what it will be like to dream in space, under 0G. Like, what will our REM cycle be like? And I'm a mom, and anyone who's been pregnant knows you double your blood volume during pregnancy. And what will that be like in 0G or under these conditions? So I don't know how we'd construct a hospital or address infection, illnesses, childbirth. I wanted to ask both of you, as someone who would build such things and someone who treats such things. Yeah.
Yeah, so thank you for the transition. So I'm part of an organization called the OSMED, which is the Organization for Space Medicine, Engineering, and Design. And basically what it does is that it creates bridges between disciplines that traditionally in the space industry don't talk to each other, or don't have the same values, or don't have the same language to communicate.
Don't have the same, like, they don't think the same goals, but they do.
No. Yeah, and in the end, we all want the mission to be successful. We all want the astronauts to be healthy. We all want them to come back alive, right? And so by creating those bridges, we are able to come up with innovations or more human-centered design in the way we create our missions. And it's pretty wonderful to see. And so about 3 months ago, I started a massive project there called Project Orbital Hospital. So we are designing an orbital hospital on the moon's orbit. I know it's crazy. And we could not do it just with space architects. We could not do it just with engineers.
This would be orbiting the moon.
Orbiting, it would be on the moon's orbit around the Earth.
Oh, okay. Okay, got it.
The way we're designing it right now, it might change. But the point of that orbital hospital is to serve different missions. If you are on low Earth orbit, you can access it. If you are on the moon, because we're about to have moon settlements very soon, you can access it as well. If you are on a mission farther in the solar system like Mars, you can come back and get some benefits from that orbital hospital. The orbital hospital, as we're designing it right now, rotates at 3 RPM. And
so is it going to have artificial gravity?
Yes.
like 2001, Space Odyssey?
Different design, but yes.
Okay.
Yeah. Yes,
Right.
kind of like the same idea.
I'm just trying to give them a visual here.
Yes. So it, we have never, as a species, tried artificial gravity quite yet. So there's a company called VAST based in Long Beach. They're about to launch the first commercial space station next year.
Try it out.
So the first space station they're going to launch is called Haven 1, and they're not going to test artificial gravity on that one. But Haven 2, from what I understand, is going to test 0.04 G, which is not perceptible by humans, but it will start testing the viability from an engineering standpoint of artificial gravity. And over time, they'll probably, accelerate it. What's interesting about artificial gravity is that it's very dependent on scale. So if you take the International Space Station, which is not a small beast, it's about like 109 meters long, if I remember right. If you double that length, and you have the center rotate at 3 RPM, what you end up with is a microgravity environment in the middle and about 1 G at the edge, right? So imagine Orbital Hospital does that. And then somewhere, 1/6 of the way in between microgravity and Earth's gravity, you can have lunar gravity, 1/6 of G. And about 1/3 in, you can have Mars gravity.
Oh, so in the same, space station, you could actually experience these different...
Exactly.
Okay.
And so we're thinking about the idea of gravity dosage, right? If you go to space and you experience microgravity, you can get some benefits of microgravity, like sleep apnea, or maybe certain bone density problems can benefit from being in microgravity, perhaps. Or maybe working out in a hypergravity or in Earth gravity environment in space might be beneficial. And we basically have close to zero knowledge of what happens to the human body in lunar or Mars gravity. So that would be a great place to start and start testing and collecting data on what happens to the body. We have so much data gaps when it comes to what happens to the human body. It would be great to have a artificial gravity station not too far from Earth to close those data gaps before we venture farther in the solar system and start risking lives with a lot of questions.
As a medical doctor, what's like the first thing you start thinking about as Phnam is talking about this station?
So we've actually been working on a concept of space ambulance with Steve Robinson at UC Davis, and whether there's an orbital hospital
Ambulance.
or there's
I don't know how to, like the name of like space ambulance. I don't know. Smush it together. Go ahead. Sorry.
or whatever, if it's an orbiting spacecraft, even if it's not a hospital, but sometimes on a larger spacecraft, you can have more medical supplies and support, et cetera. So going from planetary surface up to a craft, there needs to be a vehicle that moves quickly. And so those are just concepts that we're working on. The different types of artificial gravity have been explored a lot. Right now, they're technologically and cost-wise not feasible, but we need to keep pushing the boundaries on those things because it's important. On the other hand, you had talked about resilience, but in the same way, we look at risk prediction, and NASA's done an extraordinary job of modeling and predicting what types of things is the human body likely to experience. And so then we build countermeasures against that and supply and plan and train for the most likely scenarios, but there are the unintended, unexpected scenarios that come up. So what are going to be the options for that? And right now, as on the way to Mars, there won't be a way to bring someone back. So that's some of the hard reality is the risks continue to increase as we push further and further on the bounds.
Yeah.
On the other hand, I think we can do a lot of testing on Earth, but there are some things that we can only test in the real environment and get to the real proving ground. So I actually like tiered research where we do what we can on Earth. Everyone wants to get their experiment in flight because it's a very exciting thing to report that your project's on the ISS, but there's so much we can learn. And there's a company called LightGrav, which I have no conflict of interest with, but has some phenomenal on-Earth simulators for micro and partial gravity, but you can add comorbidities like doses of radiation, et cetera. So
wow.
we're building those kinds of programs so we can learn more in those proving grounds. And then there are the miniature satellites like NASA Ames. I just had a program I did with several of my NASA Ames colleagues yesterday. And so the miniature satellites, you've heard of CubeSat, but there are many being designed at Ames as well. So you can send projects up, generate an experiment, get the data back and the biosample very quickly, and much less costly. And this is something that we need to keep in mind. For sustainability, there are many pieces to that word. One is economics. But all of the things that we can think about that will allow sustainability are important. It's one of the reasons that Earth benefits, our Earth and how we take care of it benefits so much from the sustainability lessons in space. And both of you can speak to it as well as I can.
Yeah. I wanted to talk to Aparna because I know you talked about this idea of like, a mental shift and thinking about going into space differently. And I wanted to talk to Aparna about like, what does going into space mean for like society, right? If we go into that, like what are these unintended consequences? What do we have to think about when because you deal with dark skies and you deal with like people thinking about this, space.
Thank you. And I've so enjoyed listening to you all, truly. My mind is just aglow with ideas. I think we need to find a way to hold paradoxes comfortably in our minds and hearts. Now, from a physics standpoint, we know that nature at the atomic scale is full of paradox and finds a way to both be particle and wave without having to necessarily choose one unless an active measurement takes place. Now, I don't want to necessarily extrapolate from atomic physics to complex biological systems.
Let's do it. It's fine.
But I do think we're invited again at this unique crossroads for humanity to hold paradoxes together, right? Is there a way to hold expansionism into space with ethics? Is there a way to move away from models of conquest to community? And I love the idea of the ROE because I
Return
think,
on Earth for anyone.
yeah, I love that Because I think there are ways to move forward with a, I know sustainability is a very loaded word. I like to think of it as sustainable operations for all constituencies involved. Even if we have orthogonal goals, somehow we have to find a way to together steward a shared environment. And I'm personally learning a lot from modern astronomy telescopes that are learning to coexist with indigenous communities when the telescopes are on tribal lands. That's one example. Another example is Antarctica operating as a global commons effectively, where no one nation exerts sovereignty or ownership. And these examples are important because to move forward to the future, we need to learn from the past. We don't have to dwell in it, but we need to learn from it. And so the history of I would say some of the disasters, as well as the lessons learned from mining or water rights, that is going to apply directly to space mining, everyone rushing to the lunar South Pole because that's where all the frozen water ice is, and given the gaps in space treaties, the country that gets there first is going to get the prime real estate, but likely get most access to the water ice that will let them expand even further by breaking it down into hydrogen fuel and so on. So it is complicated, I think, but also exciting. And I just want to respectfully raise, I've learned from many of my Indigenous collaborators and communities, the 5 R's of Indigenous traditional ecological knowledge or ecological stewardship of an environment, because we're now moving to a space environment that has very little protections and regulations. And 3 of those R's I'll just raise today, which is responsibility. And in my mind, it's responsibility to future scientists, but also storytellers and language knowledge holders and artists and musicians. Reciprocity, meaning we take care of an environment that takes care of us, and relationship. We relate to a scientific environment, but we also relate to it as human beings, whether we see the moon as a revered ancestor, which, by the way, the naming of the crater for the commander's wife, I think bridge that.
On Artemis.
Yeah, on Artemis too.
Yeah.
Bridge that Western science and viewing the moon as an ancestor. And the other 2 R's are respect and reverence. I think we can find ways, because space invites all our human identities. I think we need all human ways of knowing to find solutions, because I do think whatever we do there, and I hopefully at some point, some of these big companies as well as NASA will have a chief ethical officer as well as a chief financial and chief executive officer. But I do think the way we move to space and the things we learn will be so critical on Earth. I think things might be more exciting and more lonely than we envision. And I just want to conclude by quoting Christina Cook, who was on the Artemis 2 mission when they were doing their translunar injection burn, which basically set the spacecraft leaving Earth, going to the moon, but because of orbital dynamics, they need to set the course back to Earth. She said, with this translunar injection burn, we do not leave Earth, we choose it. And I just loved that, because I think whatever we're doing, I hope it can flow back for the benefit of all of humanity.
I love that quote. She said it earlier, and it just resonates with me. I do want to point out, for our audience though, that we do have note cards, and if you have questions of things we haven't talked about, please write something down. Sam is over here, and other helpers will be collecting, and Amanda will be picking up those cards. And we're still going to talk just for a little bit. You'll have some time. Don't rush, but don't also go slow. Phnam, I could see like you had thoughts.
So many thoughts, yeah.
So many
Very
thoughts.
inspired by both Aenor and what Aparna is saying. when I hear of the involvement of indigenous wisdom in space, it just makes so much sense, because in order to, as you say, in order to build the future, we have to look at the past. And I've been privileged to be involved with some indigenous people in Australia who are doing a lot of research in bush medicine, right? Some indigenous people in Australia have been around for 60,000 years, so they've accumulated a lot of wisdom, and a lot of that can actually be very useful in helping the health, well-being, and support of people living in an extreme environment like space. And so one thing that was very obvious when we started talking to them is, and shout out to Dr. Sam Toby from Brisbane, she really wanted people to understand that, yes, there's this wisdom, but it's not something that you just pick at, and then process and then make it available to astronauts. Like, what do we give back to these indigenous people? Like, is it reference? Is it money? Is it support? Do we support them in being part of the future that we want to build together? Let's not just extract from what they're offering us and just take what we need, but really understand the wholeness of it, really understand the divinity of it, and take the whole in the way we create the future of human spaceflight. And when we think about the future, or even when we think about today, I would like to quote one of my close friends, Dara Dotz, who's a disaster naut. She always says, we are tomorrow's ancestors. So what kind of ancestors do we want to be for tomorrow?
What is a disaster naut?
A disaster naut is someone who goes into disaster environments like earthquake, floods, or war zones and fixes things with people, ingenuity, and design skills.
Oh, Aenor, I could see that you have thoughts about what's going on.
Yeah, I'm inspired so much by everyone in the conversation right now. I can't wait to hear from you as well. One thing I was thinking about what you were saying is I was sitting in a meeting in Houston. It was an international meeting, and we had representatives from the space agencies from China and Japan, but also from Russia and US. This was several years ago. And there was a lot of strife in the world, not much different than now. And I was just so stunned about the phenomenon of interdependence when you're in a high-risk and confined environment, which is just so dangerous. There's an interdependence that happens that we somehow can't quite achieve on Earth, but there's a lot to be learned from that. And I had this sense of, one important thing about going to space is we can rise above it. And that just stays in my head. So that's an important piece of what you inspired me to talk about. The other is that we have to think about how are we going to align incentives. I'm very much a person about what's the so what factor. Why are we doing this? And it's different for me than it is for some of the commercial space entities, some of the other nation leaders, et cetera. So how can we possibly find some aligned incentives that will help us get to some international treaties and some agreements, even about how much junk is up there and planned to go up there, that's going to actually end a lot of our missions. So we have to figure out how can we get to some aligned incentives, and I think that's a big challenge. The final thing I want to say is that we also have to start thinking about, when we think about going from the good of the whole, we have to come back to how are we going to understand the effect of the environment and how to respond to it on a very individualized level. Because we've been sending highly selected, optimized substrate. These astronauts are highly selected and highly trained, but all of a sudden, if you start looking at the faces of the commercial space flights, you realize now the criteria are very different that they select on. The age range is 20 to 90. Can you write a big check? Do you give a good interview? I mean, the criteria is completely different, so what I'm kind of facetiously saying is that the substrate is going to be much, much more varied. And that means we need to understand on an individual level, how are they responding to the environment and how are we going to help people? So I think those are some concepts that I keep working towards.
May I say something after you? Are you sure? Okay.
For the polite panel.
But I love listening to you both, and you, Regina. I completely agree. I think I didn't get into the extraordinary privatization of space, which the leading space treaties, including the Outer Space Treaty, did not anticipate. They envisioned an environment of goodwill and peaceful cooperation among nations. But now we have essentially individuals acting like nation states. They're running private companies, but accompany governments on tours of war zones or go to G20 summits. So it is a blind spot, and it is interesting to ask, like how, because in the Artemis II mission, not for a moment did we forget that they were representing all of us, that they were representing humanity, but not just humanity's ambitions, but our hopes and just what it means to be interconnected. We never were allowed to lose that thread. It was so beautiful. And that doesn't really come out often with, private space initiatives. It's much more, I don't know, glam. And
It's publicity.
yeah, it's publicity. And I just think I'll just offer, I think it's an interesting preview of how we represent ourselves in space, not just as our species, but as the Earth, because we don't just export payloads, right? We export our value systems and our legal policy systems. So we don't want to take the systems that are broken and haven't worked on Earth and put them in place on the moon. We want to see this as an opportunity to build something new. And it's true that when I look at how conflict has doubled on Earth since 2022, and we've lost a tremendous amount of airspace to fly in, noticed how your flights are a lot more circuitous and more expensive now relative to 2022. It's scary, and I wonder what that means for the future of space traffic management and space geopolitics. That's a thing. But I'm also so inspired by how people come together and are so altruistic in disaster zones. So there's something in us, this spark, that still continues to overcome these overwhelming forces working against peaceful cooperation. So I'm very inspired by that.
I have some questions from the audience, and I went through them. I was going to talk about an astronaut story, but I can save that for later. Well, I'll say it real quick. You said we can rise above it, and people work together in the space station. I interviewed an astronaut once, and she lived on the ISS, and she said that they had a potluck once with the other astronauts, like some from Japan, some from, and they said that I don't remember the other, Canadian, other people, and they were all sharing their food, but the people that had the best space food was Japan. And they were all eating a lot of it, and they're like, yeah, let's do another potluck. And they're like, no, that's good. Well, we're just gonna have the one. We're gonna go soon, and they had the best food, and they weren't gonna share it again. Okay, first audience question, and this is to any of you, whoever is bings in their head. Based on the higher gravity, slower time theory, how do we think about about life in space that is also a shortened life? Can our tech reduce the repercussions of aging?
Well, there's a great model for understanding accelerated aging. That is the space environment. There's been a lot of work that's come out of Sonia Schepfer's work, who looks at immunosenescence and accelerated aging at the cellular level. And so what we're learning from those experiments, and we're bringing those tissues back and then looking at some measures against them, or even understanding the mechanics of aging, cellular aging. There are different ways to think about this. So one of the things I'm very excited about is this whole field of synthetic biology. And Lynn Rothschild, fantastic researcher at NASA Ames. Two things that we're looking at around that is one of the countermeasures to aging, particularly if we look at the bone model. The astronauts lose as much bone in a month there in the microgravity environment as my patients in my clinic, geriatric osteoporotic women, lose in a year. So it's a phenomenal effect. But we don't know on an individual level who's going to lose how much bone, how fast. We have no good in-mission bone loss measurements yet. So that's something we're working on. But as a countermeasure, we're trying to figure out how to prevent bone loss because it's very difficult to recover bone. So obviously, it's exercise. It responds to the stresses you place on it. That's Wolff's Law. One of the other things we do, besides nutrition and exercise, is we're trialing different pharmacologic agents for the astronauts before they go up, and for some of them while they're up there. There's another concept going on, which I'm really excited about. Dr. Arkin at Berkeley, Lynn Rothschild, synthetic biology, where they're growing lettuce because we have to have the sustainability model of how we're going to continue feeding people, but lettuce that produces parathyroid hormone, which is a phenomenal anabolic agent for bone, meaning it helps bone growth, preserves bone, et cetera. So looking at how plants can actually produce benefit. Lynn's taken it a lot further than that, where she looks at how the cell is actually creating products of all kinds, not just pharmacologic, not just food, but actually structures. They've been designing habitats that cells and plants have actually grown into. And so that's another intersection that we could talk for a while on.
Yeah, just to add on a little bit to what Aenor is talking about from an architectural standpoint, that means that we need plants around us, to grow the nutritious, things that we need for our bodies. But also psychologically, it's great. We also, when we think about working out, fun fact, 2 astronauts cannot work out at the same time. It's one at a time, because if you have 2 going at the same time, we might not be able to control the orbit as easily.
Oh, it'll move it? It'll jostle.
Yep.
You could see it in the Artemis 2 live feed when one of them was working out. There would be this like jiggle, which was so mesmerizing to watch. I'm like, Newton's laws at play. It was just amazing.
It can also affect how much CO2 buildup happens in the confined space, which is another big risk.
Yeah, fascinating. Okay, next question. We're gonna get into oh, sorry.
Yeah, I'm sorry, I didn't finish on the aging question though.
Yeah.
The other thing we're learning about how to prevent accelerated aging that's equally important is how do we facilitate and optimize recovery? Because we know certain things are going to happen, but we're learning a lot about how can we optimize recovery. Some of that we're learning from sports medicine, and some of it we're learning from the way that we monitor and train astronauts when they return. So that's also helping us in learning more about the either slowing or offsetting aging.
Oh, and that return to Earth, because anti-aging is big. Okay, next question. We're going to talk about just SpaceX for a second. You all have, I'm reading off of this, you all provided a very humanity-forward view of space travel, which is beautiful and encouraging. Would you say that most folks in the space travel industry share the values of ethical space expansion, or is it more from a technical, fascination? So what are your thoughts? What do you think
I
about?
think it's heterogeneous. I think, as I said earlier, there are different incentives, but there are definitely some phenomenally higher order motivated people in each of the commercial space entities. And so I wouldn't paint them all with the same brush, but then those who are actually running for-profit companies, they're beholden to also make money. I think my concern is if we can't find a way to align incentives to preserve what's out there rather than just go out and exploit it, that's where my concerns lie. But there are all kinds of great people in the commercial arena as well.
A lot of people are talking about a commercial space industry. There's not going to be much of making any money if we don't send more people up there. Right now, I think it's between 14 and 21 humans at once in space, and you can't build an economy off of that. Now, that means that we need to create these commercial space companies need to create more incentives and more comfortable ways of going up there, not only for people like you and me, but maybe for people with disabilities, people who are aging, people who are paraplegic or anybody of that sort. So looking at organization like Astro Access, which is a nonprofit organization that focuses on developing innovation for people with disability to go to space. What's great about when you work for people with disability is that if you can solve for them, then you can solve for everybody else, right? And so involving these people with disability, different types of disability, in the design process of how we create the architecture, how we create the health system, or how we create the meaning of us in the future is going to be instrumental for all of these commercial space companies to be part of.
Can I tag on one more thing
Yeah,
to
of
the
course.
commercial question? We wouldn't be where we are right now without the commercial companies having jumped in and added new tech and all kinds of new innovation and fueled it with the amount of money they've put into it. Our transport to and from the ISS has been heavily dependent on Russia for a number of years. Our astronauts have to learn Russian as one of the requirements of their training because we were using the Soyuz. And so we now have our own launch vehicles again, but we have capabilities of a returning launch rocket that comes back that we use again. So that's a sustainability piece that we also didn't have before. So we're deeply indebted to the creativity and the financial advantages of having commercial space entities involved. I didn't want to overlook that when I was speaking earlier.
Yeah, Aparna, what do you think?
I agree, and I think they're often so much more nimble and can turn things around within months rather than years. Like the time it takes most academics to think about convening a committee to think about an issue, they've already moved on 2 models.
Yeah.
I will
Or just
say,
scheduling a meeting.
yeah. I will say, though, a lot of it has been from taxpayer investment and public subsidies and federal contracts. So again, fully acknowledge the nimbleness and the innovation. And it is important because now we're self-reliant again with space traffic. But at the same time, I would love to see some benefits now come back to the public taxpayer. I think on the previous, I mean, there was a number of questions on just aging. But
Yeah.
there was one that the immediately previous one was on.
It was, I think the first one was aging.
Yeah, but then
Yeah.
the one right before this, I'd wanted to add, and no worries if you can't
Yeah.
find it. Like if I think of it, I'll say it. I do really think that there's really an opportunity here to. I think both of you have talked about the possibility of a lot of medical progress and then also building specific environments. And I will just say on the aging issue, just at a completely unscientific observation, but which is tied to the research of Maori scholar Linda Tuhi-Weiss-Smith. She calls it a time of manufactured urgency. I do think rushing is very aging. I don't know if you, like me, feel aged 20 years by the last 6 years, but I do. And I do think that as we go to space, like hopefully we can learn more about not just the biological ways we age, but the cognitive and other ways we age by the pressures of the environment, like how we perceive how rushed we feel with time. Yeah.
Yeah.
I think that's a really great principle. And when we've talked a lot about physical, but the psychological, the behavioral sciences, the team dynamics, that in itself is an important field that a lot of work is being done on. That NASA identified 5 major hazards to human travel, and one of them is isolation, confinement. And when I talked to a good friend of mine who's a former astronaut, Kate Rubins, and about some of the stressors, sometimes it's relieved by seeing Earth, by seeing the planet. Sometimes it's by seeing greenery or communication with your family, which they can do now, harder when we go to deep space. But there's another type of stress. It's not just the danger and the cognitive overload of the amount of work or the type of work they're doing, but it's also the pressure. There's a dreaded red line. Every 5 minutes, there's an assignment for 12 hours. And that piece of it, I think, needs to be studied a little bit more. We've studied a lot of the other aspects that you would assume would be stressful, but I think that's a component where we have opportunity to look at.
Yeah.
And that can be quite aging.
I want to kind of, we're getting towards the end here, but I want to give each of you a time to kind of have a closing thought. So, and this was Aparna's idea, not mine. But Phnam, what, like, after this conversation, what's like your final thought? What is the takeaway you would like this audience to have?
I think in general, we have moved on from a survival-based way of seeing human spaceflight, and I really wanted to be human-centered, right? Human-centered design, really thinking about who we are as a species and what we are exporting into space. What are the most natural things that we're doing as humans, like having sex and having babies and you know, like having bad days and having relationships, and export all of that in responsible ways in space instead of shutting it down, because we have done that for quite a few decades out of necessity, but the future of human spaceflight will have all the colors and all the imperfections that humans can provide.
Wow. Yeah, Aenor, what are your closing
She
thoughts?
sets a high bar.
Yeah,
I'm basically
you said it even higher.
a very altruistic person and a practical person. I'm a bonehead orthopedist. We look at the x-ray, it's broken, then we did our work, and over here it's fixed. So I always care about the so what factor. So when I think about should we go, are we going, where are we going, how long, et cetera, it's always to what end? What are we going to gain from it, and how can we do it and create the least amount of harm? And benefit the most people and benefit our planet and actually not damage other planets, because we have a great potential for doing that. And so that's the framework that I look at a lot of this in, and you could hear from my prior comments. And I think that goes back to one of the R's you talked about, which is the responsibility. And also for me, it's what's the risk and what's the reward.
Aparna.
This is a story that's still being written. It is your story too. It is our story. And we need your help writing it for the future, so that, as was mentioned earlier, we can be the elders that the future deserves.
Oh, that was so succinct.
I think that call to participation is really wonderful, and the democratization of science and excitement that's growing again around this, I think, is really an important part of. Can I just say one last thing?
Yes,
I really
of
want
course.
to thank Aparna, because as an ancient object, I feel very comfortable that you have such respect for us.
I want to thank all of you for being here. I was just getting mesmerized by some of, your thoughts and how we're answering these questions. I want to thank Amanda and Sam for putting this together. Woo! And the AV, all these people that are running our mics, and the audience. Thank you so much for coming, especially the people who sat closer. But thank you so much for talking with us today. I had a great time, and I'm going to be hanging out here. So if you do have more questions and we didn't get to yours, which I didn't get to all of them, but I didn't want to, keep going and hold you too long. But if you have any questions, I'll be here. I don't know about you all, but thank you so much.
Thank you, Regina.
Thank you so much.
Thank you.